Hello folks, in this video we'll mostly focus on the injection molding defects and the ways to prevent those defects in terms of majorly, in terms of design or the molding process. So some of the defects already I explained in my previous video, so here we are going to focus on some major defects and the ways of preventing them. So let us see flow lines. So what is flow line? The flow lines appears as a wavy pattern, often slightly different color than the surrounding area. So generally it appears on the narrow section of the molded component. The flow marks won't typically impact the integrity of the component, but they can be unacceptable during the inspection process, because the inspection is more focused on the design, finish and look of the products, and there will be criteria already defined in the inspection procedure, and it can be categorized as a defective part. So the causes of the flow lines are the variations in the cooling speed, the difference in wall thickness and the low injection speed. So what are the ways to mitigate the flow lines? So the first thing is increase the injection speed, pressure and material temperature. Second is round corners for part or mold, so it has to be taken care during the design phase. We are rounding the corners in order to maintain a smooth flow of material. Then relocate mold gates to create more distance between them. So having a sufficient distance between the gates helps the molten material to pass and fill the entire component area easily. Next is mold coolant to help prevent the material from cooling too early during the flow. So material sometimes tend to cool so early, and mold coolant can regulate the cooling time. So there are different mold coolant to be used during the injection process. The last one is increase the nozzle diameter to raise flow speed and prevent early cooling. The nozzle diameter of the injection mold can be at a higher diameter so that more molten material can pass through to the mold. So that is one way to reduce the flow lines. So here you see some of the example of the flow line. Next is warping. So warping is the deformation that can occur in injection molded products when different areas of the component shrink unevenly. So that is basically causing because of the uneven cooling in two different areas of the part. So when there is a shrinkage, different shrinkage in two different areas of the part can undergo warpage. So maybe before getting into the warping, you can see understanding what is shrinking. So you can see here amorphous and crystalline plastic, how it shrink I actually shown in this picture. So for the amorphous plastic, there is a more shrinkage in the direction of the flow. For the crystalline plastic, more shrinkage in the direction perpendicular to the flow. So any element of the part shrinks at different rate than any other element. So the difference creates internal stress. As I said, the warpage is caused by the difference in shrinkage. This difference creates internal stresses. If these stresses exceed the part's structural integrity, the part will warp when it is ejected from the mold. So what are the causes of warping? So the warpage is caused by variations in the cooling speed, excessive temperature or low thermal conductivity of the molten material, and difference in wall thickness. So what are the mitigations we can implement to reduce the warping? Ensure the cooling process is gradual and long enough to prevent uneven stress on the material. Second is lower the temperature of the material or mold. Third is try switching to a material that shrinks less during the cooling. So some materials tend to shrink more, so that is more risk of having difference in shrinkage within the part. Then redesign the part or mold with uniform wall thickness and part symmetry to ensure greater stability in the part during cooling. So let's see some of the images. So you can see the images of the part wrap edge. So the part to be straight, intended to be straight, but you see it is at in a curved stage. Next is weld lines. Weld lines can appear on the surface of a mold part where the molten material has converged after splitting off into two or more directions inside the mold. The hair-like weld line is the result of weak material molding, which lowers the strength of the part. So what are the causes of a weld line? Two or more fronts molten material need to maintain a certain temperature when colliding each other. So when the molten material pass through two different directions and when it's collided together within the mold, if both are in the different temperature, the weld lines can happen. So otherwise they become partially solidified and won't sufficiently bond where they meet, resulting in weld lines. So what are the mitigation plans for the weld lines? Increase material temperature to prevent partial solidification. So raise injection speed and pressure to limit cooling before the material has filled the mold. Redesign the mold to eliminate the partitions. The last point is switching to a material with a lower melting temperature or low viscosity to allow faster flow that prevent the early cooling of the molten material. Here you see emerging fronts. After a pause, you can see that the molten materials joined in between the holes and create a weld line. So that's not acceptable and the part gets weaker in that area. Next is voids. The voids are trapped air bubbles that appears inside the finished mold component. You can see the images of voids examples. You can see the plastic compounds with a lot of voids inside. The causes of voids are inadequate molding pressure to force trapped air out of the mold cavity. The next is the material closest to the mold wall cools too quickly, causing the material to harden and pull the material towards the outside. So when the material gets pulled towards the outside, there is a void can be formed inside the material because of the cooling variation. The material itself may be especially vulnerable to voids if its density changes significantly from the molten to hardened state. The difference in wall thickness is another cause. So what are the mitigations to avoid the voids? Raise the injection pressure to force out trapped air pockets. Next is choose a grade of material with lower viscosity to limit the risk of air bubbles forming inside. The last is place gates close to the thickest part of the mold to prevent premature cooling where the material is most vulnerable to voids. Next, sink marks. The sink marks are small recesses or depressions on a flat and consistent surface of a molded part. This can occur when the inner part of the mold component shrinks, pulling the material from the outside to inward. So you can see the images where there is more wall thickness. You can see a small sink marks formed on the surface, so it pulls the material inward and formed a kind of depression. What are the causes of the sink marks? The material cooling too slowly near the exterior of the part, and the material tend to cool faster inside. This result shrinkage. The materials in the inner molecules pulls the outside material inward, leading to a depression. Next is sink marks are more likely to occur in thicker parts of the component. So what are the mitigations can be done? The increase holding pressure and time to allow the material near the part surface to cool is one way. Next is increase cooling time to limit shrinkage. Third is design the mold with thinner component walls to allow the faster cooling near the surface. So these are the ways to reduce the zinc marks. Next is jetting. Jetting is the deformation in the molded component that can occur when there is an initial jet of molded material injected into the mold cavity that starts to solidify before the cavity is filled. These are the examples of jetting in plastic components. So here you can see the material may be pushed too fast and cooled so quickly, formed this kind of small patterns inside the product. So what are the causes? The causes are the excessive injection pressure, the low thermal conductivity of the molten material, and difference in wall thickness. These are the causes of jetting. And what are the mitigation? The mitigation is reducing injection pressure to prevent rapid squirting of the material into the mold cavity. And second is increasing material and mold temperature to keep the initial jet of material from solidifying early. And the last is designing the mold with the injection gates located such that the material is directed across the mold rather than lengthwise. So instead of placing a gate only on the one side, you can distribute multiple sides with a proper spacing, so that the jetting can be avoided and material flow or fill the mold cavity more uniformly. So these are the defects caused by process and design. So we'll see some of the defects caused by poor or mold design. The first is flash. The flash is the excess of mold material appears as a thin layer at the edge of the component is the flash. The flash appears because of the material flowed outside of the intended flow channels and into the space between the tooling plates or at the ejector pin. The process of reworking a mold product with the flash often introduce trimming the excess material as a secondary operation. So you see some of the here you can see some of the flash samples. You can see the side of the plastic component has small thin plastic. This can be removed by secondary operation, as I said before. So what are the causes? The causes are a poor designed or worn and degraded mold is the most common contributor to flash. Second is excessively high mold temperature or injection pressure can also cause flash. And third, the material flowing through the mold cavities can force its way between the plates when the plate clamping force is not sufficient. So what are the mitigation plans to reduce this kind of flashing? Retool or redesign the mold. And second is increase plate clamping force to confine material flow to the channel. And third, adjust mold temperature, injection pressure and ventilation to provide improve material flow. The next one is short. The short occurs when the flow of molten material doesn't completely fill the cavity in the mold. The result is that the molded component is incomplete after cooling. So you can see the short samples. Here you can see that the molten material is pushed into the mold and the material is not sufficient to fill the entire mold cavity. So this can cause short. So what are the causes of short? Flow restriction resulting from narrow or blocked gates. The material is too viscous or the mold is too cold to allow the molten materials to completely fill the mold before cooling. And next, the trapped air pockets may hindering the proper flow. And the last one is inadequate injection pressure. Now what are the mitigations? The mitigations are redesigning the mold with wider channels or gates for better flow. And second is increase injection speed or pressure. And third is increase mold temperature to prevent material from cooling too rapidly. The last one is add additional air vents or enlarge existing vents in the mold to allow trapped air to escape. I will see some of the defects caused by material. So the one is discoloration. The discoloration occurs when the molded part is different color than the intended color. So you see some of the discoloration samples here. And what are the causes of discoloration? The leftover pallets in the hopper or residual resin in the nozzle or mold from a previous production run. If after the production run, if the nozzle or the cavity or the path is not clearly cleaned, it can cause a mixing of colors. And next is thermal stability of the cooling agent. The mitigations are: ensure that workers properly clean the hopper, nozzle and mold between the production runs to eliminate any residual pallets or base materials present. Next is consider using a purging compound to remove excess color from the machine. And next is ensure using a color agent with adequate thermal stability. The last one is ensure that the master batch is evenly mixed for constant color output. And the last one is delamination. If you find thin layers of the surface of the molded part are easily separating or peeling off the underlying material, you are seeing a molding defects with the delamination. So what are the causes of delamination? Contamination on the resin, the presence of foreign material, incompatible material formulation, excess use of mold release agents, excess moisture on the mold. These are the causes of delamination. So what are the mitigations? Increase the mold temperature or pre-dry the material properly if excess moisture is an issue. Ensure the workers are properly storing and handling the resin pallets or base material to prevent contamination. And the last one is consider redesigning the mold with the focus on the injection nozzle to limit your dependence on release agents. So overall, these all are the defects caused by the process of design and defects caused by the poor mold design and defects caused by the material. And also we have seen the mitigation plans in each category. So this is the really important when you're really working on a manufacturing sector, when you may face unexpected defects like that, even though your design is good. So these are the actions to be taken or considered to eliminate them. So I hope this is helpful. Thank you.